Hello everyone and welcome. Today we're looking at preparation of alkenes. And alkenes are chemicals that contain carbon-carbon double bond. So for example, you could have something like that with a double bond there. So that will be an alkene. You could have something that has two alkenes, that's called a diene. You could have even a cyclic system with a double bond. That will be an alkene. And there are so many different types of alkenes. Now, the first method for alkene preparation is by dehydrohalogenation. So when you see this word hydro, it means hydrogen. And then halogenation means a halogen. So we use X for that, which could be chlorine, bromine, iodine, or fluorine. That's group 7A. So dehydro means we lose HX. So we lose hydrogen and a halogen. So for example, if you have that as a starting material, the alkyl halide, so it has a halogen there, and remember that X here stands for any of these halogens, chlorine, bromine, iodine, or fluorine. And then you react that with a base. The base will pull out a hydrogen or a proton at the next carbon. So we see the carbon with the halogen is this one, then the next carbon is this one here, and the base either has a minus charge or electron pair, and it will use that to abstract or pull out that hydrogen, and then the carbon-hydrogen bond will flow to make a double bond, and at the same time you break the carbon-halogen bond, and therefore you end up with the halogen leaving. And the product for that is going to be, now we made an alkene there after we lose the hydrogen, and then the halogen left. So we get an X minus. And remember, this could be an Cl minus, Br minus, I minus, or F minus, depending on which halogen you're using. I'll show you another example. So in this case, the carbon with the halogen is this carbon here, and the halogen is a chlorine, and therefore you have various possibilities. You could have hydrogen on this carbon here leaving. So when you react that with a base, it could pull hydrogen from this carbon, and therefore you end up with this alkene, the double bond between the carbon with the chlorine and the carbon where the hydrogen left. Or you could end up with this other product. Just to differentiate, I'll add a carbon here. So now you could also end up removing a hydrogen from that carbon, and that will give you this product, where now you have a double bond between those two carbons. And then the last possibility, let me just draw the background or the backbone. You could end up removing the hydrogen from this carbon, and therefore you end up with a double bond in that position. So this gives you three possible alkene products. Which one is more favored? Using what's called the Zaitsev's rule, which states that the most stable alkene is favored. The most stable means the most substituted alkene. That means you count how many alkyl groups are around the double bond. So in this case, when you look at this alkene, how many alkyl groups does it have? There are no alkyl groups in this position because you have hydrogen and hydrogen, but here you have 1 and 2, and therefore that's a di-substituted alkene. And then compare with this one here, where you focus on the alkene carbons, carbon-carbon double bond, and then you count the number of alkyl groups around that double bond. I'll use a different color. Here we have 1, 2, 3, and 4, so that becomes tetra-substituted alkene because it has 4 groups. And then this last one here has 1, 2, and 3, so that becomes tri-substituted alkene. The first one was di-substituted, the second one was tetra, and the last one is tri-substituted. And you can clearly see that tetra-substituted is the most stable because it has 4 groups around the double bond. So following Zaitsev's rule, the major product is going to be this one here. Thank you very much for your time. Please stay tuned for the next video where we're going to be looking at dehydration, which is also an elimination method just like dehydrohalogenation, and it's a method for preparing alkenes. And then later on we'll also look at Vedic olefination or Vedic reaction, and then later on we'll look at hydrohalogenation of alkynes. Alkynes have carbon-carbon triple bond. And then lastly we'll look at dihalogenation. That's where you add two halogens across the triple bond. Thank you very much for your time. Please support the channel by subscribing and also by commenting and liking the videos. Bye.